Hello everybody, this is the second clip for chapter 3. For this clip, we are going to talk about the so-called vectors. Vectors is a quantity that has both length as well as the direction or the orientation. Okay, so it's the same thing as we learned in physics. So here in math, the vector usually have the initial point and the terminate point, and we are going to indicate by the arrow like this. So this one is the vector from A to B. Okay, and of course for this chapter we are going to talk about the vector in three-dimensional space. Okay, so usually if we talk about vector AB like this, so it's already indicate the initial and the terminate point. So usually if we have 2 points, okay, A which is x1 y1 z1 and the B which is x2 y2 z2, so we will really need to look at the point that we are going to indicate by the parenthesis like this. Okay, so if we talk about the point, we are indicate by the parenthesis like this. The vector A, okay, so usually we have the arrow on the top of the A like this, which is represent the vector AB. So it is the one that initial from A and then terminate at B like this. Okay, it is represented by x2 minus x1, y2 minus y1, and z2 minus z1. Okay, and you are going to indicate the vector by this wedge parenthesis like this. Okay, so these vector contains 3 components. Okay, the first component, the second component, and the third component, and it is using the coordinate component of the terminate point first minus by the one with the initial point. Okay, and you cannot switch. Okay, it has to be the terminate minus the initial, or sometimes as we learn, we are going to write this way that AB, it is the B minus the A. Okay, and then the length or the magnitude of the vector, usually we using the absolute value, or sometimes we use the double absolute value like this, and it is using the Pythagoras theorem. Okay, so the length or the magnitude of this vector is simply a square root of a1 square, a2 square, and a3 square. So this means that your A, it is a A1, A2, A3 like this. Okay, contain 3 components. All right, so it's going to be the first component square, the second component square, and the third component square, and don't forget to take a square root. Okay, to add the vector, it is very simple. We just adding the first component together, the second component, and the third component, just like this. So if you got a1, a2, a3 as a vector A, and the b1, b2, b3 as a vector B, then the a plus b just simply a1 plus b1, a2 plus b2, a3 plus b3. And if you need to find the a minus b, then you just do a subtraction in each of the components, same thing. And if you are going to have a scalar multiplied by this vector, you just multiply the scalar to each of the component of the vector. And to write a vector, we can write it in this way. Okay, a1, a2, a3 by the wedge parenthesis like this, or you can do it using the so-called unit vector. Okay, along each direction. So I is a unit vector along the x direction, j is a unit vector along the y direction, and k is a unit vector along the z direction. So it means that your a1, a2, a3 as a vector a can be represented by a1i, a2j, a3k, just like this. Okay. Now the properties of the vector. For example, I mean, because you when you added the vector, it's just simply doing the addition for each of the component. So it means that you can do a plus b or b plus a. That'll be the same thing. If you are going to have a, b, c added together, okay, you can do b and c first and then followed by a, or you can do a and b first and followed by c, or sometimes you can just ignore the parentheses because they'll simply be the same. This is so-called the associative property. And then the next one is something like identity. We are going to have the vector 0. Okay, of course, the vector 0, it means that all components, okay, they're all 0. So a plus the vector 0, it's just simply the vector a itself. And negative a, it just simply negative 1 multiplied by vector a. So it is negative a1, negative a2, and negative a3. Okay, so you just distribute the negative sign to each of the components. And the vector a plus a negative of vector a, it is a vector 0. And another thing is that if your vector a going this direction, the negative a will be the same, who has the same length or the same magnitude, but having the different direction. Okay, just like this. If you have a scalar multiply the a and the b, then it means that your scalar can multiply with the vector a and the scalar multiply with vector b. It is distributive. If you got two scalar added and then multiply by vector a, you can distribute the a to each of the scalar. If you got two scalar multiply and then multiply with your vector a, okay, you can do your scalar first, or you can do, I mean, the scalar with the vector first and then follow by the second scalar c. Okay, it doesn't matter. Or you can just write down as c d a without parentheses. Okay, and if your scalar is just simply 1, then 1 multiplied by vector a is just a vector a itself. Okay, so this property is like a common sense properties that you should be able to know. Okay, so for example, just one thing that we need to emphasize. Okay, this one, we going back to your two-dimensional space. The point 5, 2, okay, it's just simply the point. However, the vector, okay, 5, 2, okay, is the one that start at origin, okay, and then terminate at that point 5, 2. Okay, so here is the vector. So the vector got the length or the magnitude as well as a direction, but the point is simply a position on the space. Okay, so the vector is a quantity. Okay, this one is a position. So what if you need to find the sum of these vectors? Okay, so this is a 2.1, let's say. So this one, the sum of 3, negative 1, 2 added by 2, 1, 0. It just simply what? 3 and 2, negative 1 and 1, and then 2 and 0 added. Okay, each of the component. So you got 5, you got 0, you got 2. Okay, and to illustrate geometrically, you actually need to know how to draw a three-dimensional space very neatly. However, roughly speaking, okay, if here is the vector a there is a vector b, let's say that it starts from the same origin, okay, then the a plus b is usually represented by the diagonal, okay, of this parallelogram, okay. So here is actually a plus b, okay, just like this. Or I mean, if your a is like this and your b, okay, is the one that the initial point of b is the same as the terminal point of a, okay, then there, okay, complete your triangle here is your a plus b as well, okay. So it depends on how you represent it using the picture. So let us talk about the 2.2. This is also very easy. If you want to add them up, okay, so it is a negative 1 and 0, 0 and 4, 1 and 1. So you got negative 1, 4, 2, okay, as a result. Okay. Now, if you need to find the so-called unit vector, okay, so if we are given vector A, okay, a unit vector is of A, okay, is a vector that got the same direction as the A, but the length or the magnitude of 1, and it is simply calculated by 1 over the length of A, okay, multiplied by A, 1 over the length of A multiplied by A, okay. So if you need to find a unit vector that has the same direction, this one actually got two problem, okay, this is 3.1, this is 3.2. So let's say that this is your A. So you want to find a unit vector that got the same direction as 4, negative 3, 0. So the 3.1, the length of your A, it is simply a square root, don't forget a square root, okay, of each component square. So you got 16 and 9, which is a square root of 25, or is simply a 5. So a unit vector of this one, it is simply 1 over 5 and 4, negative 3, 0. Or sometimes you may write it as 4 over 5, negative 3 over 5 and 0, okay, it does matter. How about the second one, number 3.2? What is the length of this one? 4i 2j minus k. So it's a square root of each component square. So it is 16, 4, and 1. Okay, this one is negative 1, the whole thing square. So you have this. So it is a square root of 21. Okay, so the unit vector of let's say the 4i, okay, the 4i, the 2j, and the negative k, it is simply what? Is 1 over a square root of 21 and then multiply by 4i 2j minus k. Okay, that's it. Simply as it is. Okay, what if you need a, let's say, what if you need the vector that is the same direction of 4, negative 3, 0, but has the magnitude of 5, okay, oh, let's say not 5, a magnitude of 7, okay. So go back to your number 3.1 again, because this 4, negative 3, 0 is the same vector that they're talking about, right? So here the unit vector, don't forget, it's a vector that got the same direction as A but the length of 1. So it means that for this question the answer can simply be the vector of 1 over 5 4 negative 3 0, because this one will contain the same direction as A, and here is your A, right, in this context. But this one got the length of 1, a unit length. So if you need a length of 7, you just simply multiply the whole thing again by 7. Okay, just like this, very simple. All right. Now look at the number 4. If your vector v lines in the first quadrant, okay, so when we talk about the so-called quadrant, it means that you just going back to your two-dimensional space, okay, because you got 4 places, okay, divided by the x and the y axis, so which is called the first, the second, the third, and the fourth quadrant. Okay, so here it's saying that your v is lines on the first quadrant, and your v got the length of 4 and make the angle of pi over 3, okay, on the positive x-axis. You want to find your v in a component form, okay, in a component form. So you may need to recall yourself trigonometric function, okay, the trigonometric function on the unit circle, okay. So let's say that if this one is a angle theta, then here instead of x and y, it is the x and y that depends on the theta along, I mean, this circle. So this one is a cosine theta and the sine theta, and then you know that this length is simply 1 because of the radius. But this one, this is almost the same thing, okay. So your theta is pi over 3. So if we talk about the pi over 3, okay, with the length of 1, so here you got a what? A cosine of pi over 3 and sine of pi over 3. Okay, here has a unit length, right? But you need the length of 4, so just simply multiply the whole thing by 4. Okay, so let me write down as a vector. So you use the wedges parentheses like this, okay, or you can say that your vector v, it is simply what is a cosine of pi over 3, it is 1/2, and sine of pi over 3, it is square root of 3 over 2, or you can simply multiply a 4 in, so you got 2 and 2 square root of 3. Okay, so that will be your vector v. Okay, that will be your vector v. All right, so we are going to stop this second video clip over here, and then the next one we are going to talk about the next concept, okay, of the vector, which is the so-called dot product, okay, or the scalar product. We'll see you on the next clip.